Yes.
6.7.
Oh, good. Perfect. So 6.7 says reference number 19. I should have worn I got this shirt that's got a dude shooting a basketball. It has the equation of the arc of the basketball as it's approaching the hoop. Right? So this is this one is a t-shirt cannon, right? I think. One of those t-shirt, what do they call them? Tightly rolled t-shirts into the stands, knocking some fans out. And that shirt follows a certain trajectory. So here's what's really interesting about number 20. The way it's worded, and they put this in italics, I think, right? Determine how long a t-shirt has been airborne if it is caught on the way up by a fan 100 feet above ground level. So the equation they give you is, I think, this. I forgot what goes here. 10? So that's the height of the shirt. And if I said, when is this marker, like 6 feet off the ground, if I threw it up in the air, well, it'd be 6 feet off the ground here, roughly, and then again over here. If I threw it up in the air like that, I have one eye. I should stop trying to do stuff like that. Right? So it's going to be at the same level twice. Does that make sense? So that's really, and that's why they say on the way up. So if this is 100 right here, they want to know when is the height 100. Well, how often does the height of 100 happen? Twice. Which one of these is on the way up? This one. What does that mean for us? I'm going to take the smaller time, because there are 2 times at which it's, but on the way up, he would catch it here, so it didn't even have a chance to come back down. All right, but how do I do this computationally? I want the height to be 100, so where do I put 100 over there? So for this, so it'll be 100 equals this business, get everything on one side equal to 0. You're going to factor. You're going to get 2 valid times. So this problem is interesting. I'm going to eliminate this time because that's coming down. I like it. That's why that one word is in italics, on the way up. Wait a minute, on the way up. Okay, I like it. Maybe. Is that all right? So you are just making the height 100. Don't put 100 in for time. It's not 100 seconds later. It's 100 height. And then you're trying to figure out what the time is. Is that all right? Is that all right? Okay. So that was a really good question. That's a question I was telling somebody earlier. If I don't get that question, I'm worried that people skipped it or something. Anything else from homework stuff?
Also in section 6.7, while I'm doing the homework, I run into a word problem, but I forgot what I think it's number 10, I'm not sure.
That's the one about triangle.
The 84 symmeters, 84, page 488.
48 or 84.
I think that one's 25.
Oh, it's 25, yes. That was hard for me.
There you go. There's another really good one. You ready? So somebody asked me this question in my class, in my office, and I do have a picture framed of Homer Simpson in the Scream. Right? And it was easier for me to point it out. So when you have a picture framed, here's the frame. And very often, not like my picture, but very often this is the same all the way around. Right, so that's really what the question is asking, is what is that width? So it's here, it's here, it's here, and it's here, and what do you want to call it? W. I like it. And we know that the frame itself is, I think it's 12 by 20. Okay. So first step is how to accurately interpret the situation they're telling you, right? And then there's one last thing, the 84 you said, is the actual area of the picture you can see. So that's the area of this in here. Right? Okay. Leaving units out for now. So what the shit? Right? How does the 84 relate to these? Does the 84 relate to these directly at all? No. But the 84 is the area of this rectangle. So what am I missing in order to make an equation? I know the area of that rectangle, the inside rectangle is 84. What do I need else about the rectangle to set up the equation? What two things do I need to get the area of a rectangle? Length and width. So I need to know the length and the width of this inner rectangle. And that's where students might go, how the shit would I know that? Well, I do know what that is. So this whole thing is 12. So what is this thing? Interesting. No. What if I cut off a 12? How much did I cut off a 12 to get that?
300.
How much is this? I know, but what do we call it? W. And how many of those did I take off at 12?
2.
So what's this then?
2W.
No. I started with 12, and it took away how much? 2 W's. The whole thing's 12. I took off a W there and a W there. Well, if it was 12 minus 2W, that's what's left. So this, same thing. So what's this going to be? Can we cut to the chase on this one?
Yes.
It was 20 minus 2W. So this is the length. This is the width of the rectangle that we know the area of numerically. So I can set up an equation. I love that problem, and I would, wouldn't I? Because you have to kind of work your way in to that inner rectangle. I know 84, I got to know what the sides of that rectangle are to set up an equation. And we did that tin problem and stuff. It's sort of kind of related to that, where you take stuff off the sides. You remember that tin problem? If you were here yesterday. If you weren't here yesterday, then we did a tin problem. So what would the equation be that I can set up? What's the area of a rectangle? Length is width. So the area is supposed to be 84. What's the length of that rectangle?
20 minus 2.
20 minus 2W. And what's the width?
12 minus 2.
12 minus 2W. There you go. And then you solve that. Which will involve doing what? Yeah, you got a foil, suck the 84 over, and then refactor maybe.
I have a question.
Yes.
How do you know when you foil and when you glue?
Foiling is the opposite of factoring. So this is already factored, right? So I wouldn't have to factor because it's already factored, but it's like it's been factored too early because this side is not 0 the way it should be. So I want to unfactor this. And what's the opposite of factoring? Multiplying things out, in this case foiling. Is that cool? So when you see a problem that says simplify and you factor, you're doing the exact wrong thing. Does that make sense? It's like me saying, okay, multiply these two things, and you like start to divide it. What are you doing? But for a student, you hear simplify, and factoring feels to you like you're simplifying it, but that's the opposite. Simplify means do the operations. Factoring means undo multiplication, complete opposites. Is that cool? Is that all right? You guys doing all right? I was just telling a student earlier, when's that second spring break? Oh well, go ahead. Anything else from homework stuff? That was a good question. That's not an easy problem. I don't want you to feel like it is. I always try to show you the reasoning you need to do. If you didn't draw a picture for this problem, you're crazy. I have to draw a picture to kind of work with it. Go look at a picture, you know, just to go, what the hell are they talking about? Another kind of problem like this would be like a walkway around a hot tub or something. Do you see how this would be like the walkway around a pool or something, right? That would be a similar kind of physical problem that would have the same kind of setup. Anything else from homework stuff? Okay. Last time we made it just a little bit into, well, we basically did 7-3. Yeah, we did 7-3. So let's do a couple problems from 7-3. We're going to focus on 7-4 today. Here's a problem from 7-3. What you got, Chuck? I don't know, man. It's a new one. All right, let's see what happens. So what kind of things are these? I'll accept a few different answers. So if I let x be a number, this would be a what? What kind of number would this whole thing be? A fraction, right?
Yeah.
So you guys are like, what does he want from me? That's all I want. That's a fraction, that's a fraction. In order to add two fractions, I need a denominator. And I do have like denominators. So I'm allowed to just slap these things together. Now, 1/4 plus 2/4 is not equal to 3/8. That's insanity. 1/4 plus 2/4 is the bottom stays the same. When you start throwing variables in, you kind of assume that everything is new now. No, can't be. They have to work the same way. So what do I get on the top? What is 9 plus x minus 6?
Plus 3.
Is that cool? Over. Okay, so that's the first step. And what is always the last step in a fraction problem? See if it'll reduce, right? And how do we do that now that I've got these variable expressions? I have to really show myself what's going on. What do I have to do? Can I kill an x? And what about those 3's? Die! Or what about the 3 over 18? All right, I think I've made, we'll see. I think I've made a big enough point about that. Division can't cancel parts of addition or subtraction. 11. So what do I do on the bottom? Yeah. Now, I'll bet you $1 million that x plus 3 is a part of the answer, but let's see. Right? Not necessarily. Don't just assume it is and just do it, but I'll bet you. Because this is the only way anything can happen here, right? You're not always going to be able to reduce every fraction, though. So what is sure enough, it's x, 18, that makes 3. 6 and 3, and the 6 is negative. So sure enough, the x plus 3's cancel. What's the answer? 1 over. I love it. Be really careful about where the survivors are. The survivors on the bottom. Can't claw his way to the top. Can't like it. Okay. Game of Thrones is coming, so I got Game of Thrones imagery in my head. The Algebra battlefield. Okay. So, alright, get ready. We're going to do a problem now that's got one of the biggest, easiest mistakes to make. You should know what's involved. Almost any time there's a mistake that you can make, it involves either the idea of 0 or it involves negative somehow, right? So those are the two main, and sure enough, this is going to involve the idea of a negative. Let's see if I can make one that works. That would be really nice, Jeff. Do this. Wait, make this 3x there. There we go. All right, I think this will work. Let's see what happens with this. There's a few different ways to be careful about this. There's a minus in the middle, which minus sucks. The bottoms are the same, so I can go ahead and put the tops together. I'm going to make a mistake. You ready? 3x minus 2x is x minus 1. Yay, I've made a mistake. Exactly. So that negative is applied to what? Both of these, because it's minus this whole thing. So really, one of the fundamental things I think I want to change about the way I teach this earlier than now, like back in 88 or 90, is to really make it hammer it home that whatever I put over something, there's always an understood parentheses around the top and the bottom. There's an understood parentheses here. So then that negative's got to distribute. Just why do I not draw them? Because with the big-ass bar, I don't need the parentheses. The big-ass bar means there's a top and a bottom. But there's an understood parentheses. And that actually takes care of a few mistakes. So there should be 3x minus 2x plus 1. Kick ass. So x plus 1 over 4x squared minus 4. And then what's the last thing to try to do? Yeah. So go ahead and try to finish that out. Factor the bottom. I made one that works. Yeah, good job. Yeah. Then on the bottom you can take out a 4. And then what did I uncover here? Yeah, it's a difference of squares. And then what dies? Die. And so I get 1 over. You can leave it like that, you can bring the 4 back in, either way. What's up, guys?
Is there 2 ways to factor the bottom?
Oh, you could, I guess you could do this, right? Is this what you did?
Oh, no, I just forgot the 4.
Oh.
I forgot the 4 leading the x.
Oh, yeah.
So I just put x plus 2x.
Oh, shit.
Wait, that's what I did, is that right? Next to
Oh, so if you do take this and you go 2x minus 2, 2x plus 2, right? Don't each of these have a factor of 2? So you can take a 2 out of this and a 2 out of this, which is a 4 total. So any way you do it, you either take a 4 out first, or you take the 4 out last. Math don't give a shit, right? But I'd much rather, that's why GCF is the first thing I should always try, so then there's less stuff to worry about if there is another thing to do. Okay. Cool, okay. All right. So, if I'm you, I might be curious about what will happen, but okay if we don't do it. What's going to happen if the bottoms are not the same? Same thing that happened with numbers. So let's remember what will happen with numbers. Now let me give you a problem that's a little bit grosser than normal. Just because I'm evil. What you got, Jeff? What do I like? There we go. That's so yummy. So this would so desperately suck to attack this the normal way. So I want to show you, this is the way I show people to do this kind of problem, and it's the only way you can do it if the bottoms have variables in them. So one way to do this is to take like 48 and write all the multiples of 48, and then take 60 and see where they match. Oh my God, I don't want to do that shit. So let's do this instead. What's the real idea behind LCD? I want to multiply maybe each of them so they end up in the same place. So why is this an easy problem? 1/5 plus 1/7. What's the LCD there? What is it? 35, right? Because he's missing a 7 and he's missing a 5. All right? Then watch this. What about? That's good. I gotta go too far with that. So if I break these up, I can see what they each are missing relative to each other. Now the way to do that is, what's the biggest number that goes into both? 12. Real quick, what is the difference between these two? That doesn't mean it's always going to be 12 that goes into both, but that's a great place to start. So 12 does go into both. So what's 60? 60 is 12 times 5, and what's 48? So now you can see exactly what each one is missing relative to the other one. Right? This is where I used to say something like, if you have kids and you give them both ice cream, and this kid's like, you got sprinkles, I didn't get any sprinkles. You got more sprinkles. And then you're like, I'll eat all the ice cream. Which is why it's probably better I don't have kids. Because then it'd be really, really fun. So what is this guy missing? The other guy's got. What's he missing that he's got? 4. Because they both have a 12, right? That's the bowl. They both got the bowl, and then the ice cream, and then some sprinkles, and not the same other. Okay, so he's missing a 4, so give him a 4. It's amazing, right? I gotta love this idea. He's missing a 4. So give him a freaking 4. And what's this guy missing? 5. So give him a freaking 5. Don't the bottoms match up now? Whatever 12 times 4 times 5 is, what's 12 times 20? What's 12 times 2? 24. 12 times 20 then will be 240. So the bottom is 240, and what's the top's going to be? 28. 55. All right. You guys with me? You can use that. Now, obviously, if the numbers are smaller or something, then you don't have to do this method. But when the numbers are big and have a lot of stuff going on, this method kicks ass. Right? Maybe? No? Some of you guys are only, yeah, whatever. So then you get 83 over 240. I'm pretty sure 83 is prime. Can't like it. Okay, so let's see what this looks like. Of course, you're not going to get a problem like that. That's old, easy news. You're going to get a problem with variable shit in it. Variable shit. Sounds like a condition we never see somebody. So let's see. So now we're going to see a problem like this. I like it. Yummy. Yummy, yummy. So what was the first step we did here? We took each bottom and we broke them up to see what they had. So then we can see who's missing what. So we do the exact same thing over here. How do you break this bottom up?
X minus 3, X plus 2.
Kick ass. And I kind of draw a line through this because now it's this, right? And how do you factor this?
X plus 3, X minus 5.
Yeah, they got to both be positive. I like it. So he's been replaced by this. Is that decent? Same thing I did over here. Bam, bam. So what's the first guy missing that the other guy's got? Well, first let me ask you, what do they both have? X plus 3. So they both have that. So that's their bowl of ice cream. Now we've got to talk about the amount of sprinkles. So he's missing X plus 5. So you give him an X plus 5. And he's missing X minus 3. Now, do they both have the same bottom? Yes, doesn't have to be the same order, right? It's all multiplication. So they both have the same denominator. So now the bottom is going to be x plus 5, x minus 3, x plus 3. What's this?
3x plus
3x plus
5. Oh, 15.
15 plus
Oh, x minus 3.
I like it. Quick side note, don't even write this, but see how I could write 3 times x plus 5 plus 4 times x minus 3, right? And don't distribute, but the mistake people make, if I say to do this, is they start to kill this. Why can't I kill this?
Is it 3?
No? What? Why exactly can I not kill these two?
There's an addition sign.
There's a plus there. I can't break into an addition problem. No. Right? So what I try to teach you guys is distribute so you don't even try to do that. Because we're all human. We're going to see that shit and go, oh, I can kill those two things. Yay. No, you can't. Damn it. So don't even let yourself see that shit. What do I do on the top now? Yeah, like terms. So we get 7x plus 3 over bam, bam, bam. Please, dear God, don't multiply the bottom out. Number 1, that's just busy work. And number 2, what's the last thing I want to do? See if it will reduce. And I can see, right? I can see that, no, that can't be factored, nothing reduces. So don't multiply the bottom back out. That's crazy. Okay? Multiply the bottoms by it. Sorry. Charles are by it. Alright. Just glad to see those references still, man. Dude, yeah, I know. Yeah, Simpsons did it. Got a ways to go before they beat that. So what? All right. So let's see a couple of. So basically, the idea doesn't change. But here's a few places where it's easy to make a mistake with this. Okay, here's a huge place to make all kinds of mistakes. One thing I see happen is somebody kills those x's, for example. And again, the same reason, why can't you kill those x's? It's addition. Division don't cancel addition. Right? If it was 4x over x times 2 over x, then the x's could cancel, because then you have multiplication division that kill each other. So don't get overexcited about stuff disappearing when you have addition or subtraction in the middle. Now, here's the really big thing. This is where it gets really freaky. Can somebody tell me, don't even write this down. So I get students do this. Alright, there you go. There you go. So now that's 1 over x minus 1. The bottoms are the same. Some of you guys are like, yeah, what's wrong with that? The bottoms are the same now, Jeff. Are you allowed to subtract 1 from the top and bottom of a fraction? I mean, give me a fraction.
2 over 3.
2 over 3. If I subtract 1 from the top and bottom, is it the same fraction still? No. So you're only allowed to multiply or divide top and bottom, right? Get out of here. Get out of here. So then it gets to be really weird. You're like, well, what? Does this guy have an x on the bottom? No. Doesn't. As an x minus 1. Right? Now watch this. Does this bottom have a 10 in it? Yes. Right? Does this bottom have a 10 in it? No. But that's 10 plus 7. But when I say in it, you know that I mean by multiplication. You know that I mean by a factor. Right? So does this have an x in it? No. But this guy does. So what's he missing? X. He's missing an x. And what's he missing? X minus 1. They're missing each other. Aww. In fact, any time that one bottom is 1 off from the other bottom, they're going to be missing each other. Try it with anytime, anything you think of. This needs an 8, this needs a 7. There's no getting away from it. So let's see what we get. What's on the top here? 4x squared plus 2x minus 2. I like it. Over.
X times x minus 1.
Beautiful. I love it. And now I got to check to see what?
If the top and factor.
If the top factors. What's the first thing you notice about the top?
2 goes in.
2 comes out. So I would need factors of -2 that add to be 1. Well, I like this problem. I didn't even mean for this to happen. Yeah, 2 and 1. Which one's got to be positive?
1,
No.
2.
It's got to be 2. Why? Because it's got to come out to be positive 1, so the bigger one's got to be positive. Let me stop for a second. Is everybody cool with what's happening? First part of the problem was the new stuff. Get the bottoms the same, combine stuff, great. The last part of every fraction problem is can it reduce? And when I have variable expressions, that involves factoring, right? So we saw a GCF, bam. We saw this is not a 1, shit. Right? Now if we keep going, I can split up the middle term. Let me put the minus first one. Minus x plus 2x minus 1 all over x times x minus 1. So all I'm doing is focusing on this piece, factoring this piece. So that I can see there's a x comes out of here, 2x minus 1. And then a 1 comes out of here, 2x minus 1. Oh man, there's a problem. Let me go up. So then I get 2 times x plus 1, is that cool? X plus 1, 2x minus 1. All over x times x minus 1. Can anything cancel?
No.
No, so I'm done. You feel like that was wasted work, but you didn't know it wouldn't reduce until you did that. So, done. First step is the new stuff. This whole thing is old stuff, just reducing that fraction. Not very old, but still old. Maybe. Okay, so here's another place where it's easy to make mistakes. How are we doing? You guys all right? What happened? Everybody okay? All right. Let's see. You can do it, Jeff. Can you do it? Yes, you can. Let's just keep it simple. This is gross, I like it. Gross. So, no matter how much stuff the problem has packed into it, the steps don't change. What's the first step? Factor the bottom. So I see what they're made of, right? Well, let's see what colors working today. So this becomes,
X plus 3x plus 2.
I like it. This becomes, you see the other blue one, maybe working better. I like it. Okay. So they both have x plus 3 in common. What's he missing that he's got? Beautiful. It's like, oh, thank you. And then what's this guy missing?
X minus
x minus 3. I want to show you the way I'm going to handle this. Anybody point out what I'm going to try to make a point of in this problem? What's the trouble spot?
That top in the numerator.
Sort of. Not really. What's in the middle of those two fractions? Ah, shit.
So you want to distribute it before you FOIL the...
It's up to you. So it really is up to you. What I sometimes do is this, and this I notice that a decent number of students like this. You can always make this plus like that. Always. And then you don't forget to bring that with you. Are you guys with me? So here, what am I going to get here?
X squared minus 2x.
2x. I like it. If I brought a -1 through there, what do I get?
-5 plus x.
Good. So let me write it like this. Is that, do you guys see that? Is this times this times this. From your -1 in, it's whatever I get still has to multiply by this. But I just change the signs of what's inside. Bam! And what's it going to be over?
X times x plus 3.
Yes. I like it. So really every problem in this section is the same. It's just that some of them have these little things where people make mistakes. Now, again, I'm sort of in a place where you got to be careful. Can I do this? Probably not, because I didn't draw a line through there. I would have done it. Why can't I cancel those? It's part of an addition problem, so of course I can't cancel those. So I get x squared minus 2x. What do I do over there? Yeah, so I get x squared minus 3 minus 5 is minus 8. Multiply them, I get 15. This problem is definitely one that involves a little bit of what I like to call math stamina. I think we've talked about that before. You did like, I've done a lot of work on this problem. That's enough. You won't notice I didn't finish it. And then you get here 2x squared, 10x, plus 15. For this to work, what would you have to find? Factors of 30 that add to be 10. There are none. 3 and 10 don't make 10. 2 and 15 don't make 10. 5 and 6 don't make 10. So you're done. You can't factor the top, so nothing could possibly cancel. So the steps don't change. Break the bottoms up. Give whoever's missing what they're missing. Be careful about negatives. Be careful about what's really there. But still, the steps don't change. Then it's cleanup time, right? Distribute, multiply, get your like terms together. And then the very last step is always see if it reduces. All right, so here, let me give you one for you guys to try on your own. Let me give you two. I'll give you a nice one, and then a not so nice one. Oh, what you got, Jeff? There's one. That's supposed to be the nice one. This one, let's see. these problems, they each kind of make this point for me, but if you still have trouble with just factoring, just work on that. You can't even start chapter 7. I mean, my God. Oh, you're about to stop.